right now.
That's hella funny.
Okay. You ready? Maybe you can just do them all, and then I don't even have to. Never mind.
Were these words being on a test?
We could do that.
No.
They're not hard words. In fact, I took this out of my algebra binder. I think number one you will all know.
Very good.
You're good.
I know.
What is it? You don't know?
Isn't it a letter that takes up a number?
Yeah,
It like interprets a number.
Yeah, it's used to represent a number.
Pretty much, yeah. It doesn't always have to be a letter. A symbol used to represent a number. Most of the time we use what?
Letters, X, Y.
X and Y. Like X. Oh, now we get to the hard ones. What's coefficient?
Isn't that like the y-intercept? No?
Mm-hmm.
I remember like this.
Isn't it the number multiplied by the variable?
Yes, that is exactly it. The number multiplied by the variable, usually written in front of it. You never write x2, do you? Usually you write 2x. So either the number multiplied, generally written in front of, I'm just going to put an arrow to make it faster, like 2x, the 2 is the coefficient. Like remember when we were factoring and I was like, oh, these have a leading coefficient of 2 plus. That's the ones where it's like 3x squared, or the front coefficient is pi. Oh, I don't have this one. Exponents, you don't know that one. I don't even have to do that, right? We're not going to write that down, right? No? Salvador?
No.
Why is that funny? These are weird today.
I'm not.
I am too. It's Friday. No one's here. You know what an exponent is, Karen? Tell me.
It's what you multiply a number by itself or to a power.
It's the little number up top that tells you how many times to multiply that thing by itself.
A power is a different thing.
Power is not a different thing. That is the same thing. I believe.
The power is outside of
How did we get out
that.
tonight? 28.
Could be. Let's look at an exponent. I believe they're interchangeable. Power and exponent, same thing. Tell them to come on in.
What?
Tell them to come on in.
No one's over there.
It's going around.
Same.
This is crappy. Let's see. What's an expression? You know what that is? Anybody? Anybody?
Isn't it like an equation but without the equal sign?
Yes. Like an equation, but without an equal sign. I was just gonna, like a number sentence, I guess. I don't really have like a definition. It's like these, 2a plus 3a plus 5. That's an expression. These. Or 4 minus 3x plus 7 plus 2y. I guess we could write a number sentence. They have variables in them too, usually. I don't know. They don't have to have variables. It could just be like 3 plus 5 times 2 minus 7. That's an expression. Something that you're going to probably simplify later. I don't know. What's an equation?
It has the equal sign.
It has an equal sign. Equa. Not an L, equal sign. there's just expressions on either side. You know what an equation is. Has an equal sign. That one I'm not really worried about. I figure you got it. Like 7x plus 2 equals 10. There's an expression and it's equal to another expression. Therefore, it's an equation. Oops. What's a term? Part of the semester?
Isn't it like, no, that's funny. A part,
In
it's
math.
like a set. Yeah, a set of
It's like-
numbers, like,
Set.
between the plus and
It's
equal.
like, I don't want to say a set because a set means something else.
Isn't
A
it
set means like a
terms
collection of a whole bunch of different numbers.
A term is like 2A, right?
2a is a term.
It's the thing before plus or equal or minus sign, or in between or whatever, right?
There doesn't have to be a plus or
Did
equal.
everyone fix
Oh
it?
wait,
You
before
said
plus
you
or
rolled your
equal
eyes.
minus. Kind
You
of.
I
know that
do.
on Snapchat on everything?
I do.
Okay, she bad?
I'm gonna go with the parts that
Daniel,
make up expressions
Vodka.
like 2x plus 3x plus
It's 'cause
5.
I always roll my eyes in pictures.
Me too.
Those are all terms. Term. Basically, it's separated by plus and minus signs. So like if you have 3 minus 4y squared plus 23x minus 8y plus 5y squared. How many terms are there?
5.
5, yeah. 1, 2, 3, 4, 5. It can get confusing when you start throwing in parentheses.
Isn't it still a part of the term?
Yeah. It's like you start going 2 plus 3x times 3 minus 4x.
So is it 2 terms?
4, 10, 4, 5.
Depends on what you're doing.
Half terms.
I don't know. You could consider it like if you look inside the parentheses, there's 2 terms. But when you look at the big picture, since this is multiplication, you can consider that one term and that another term, and so there would only be 2 terms.
It just depends.
Because those are not separated by addition or subtraction, they're multiplied together. Wait, that would be all one term then. It's very confusing when you get to that.
Wouldn't it be 2 terms if there's a plus or minus in there? But you're multiplying.
Yeah, well,
So
I guess you kind of have to simplify it first, because then there would be a whole bunch of terms. I don't know what I'm talking about here, I'm just making stuff
Should
up.
we have learned this like before math?
Yeah, this is
Or
like
real?
8th grade.
Oh, yeah.
But it's okay. If you don't use them, sometimes you forget them. You know how to combine like terms.
Yeah.
That's when you add the ones together that are the same thing. That's on here, but we need to write that down. What's it mean to simplify an expression?
Simplify to
Condense it, combine like terms. They're the same thing. Okay, that was on here. See, I had all this stuff on here, and I'm like, this is like from Algebra 1, so I don't think we need to write all these down. Like those are like terms, like terms, like terms. All right, you know that? Good. Yeah. Okay, just a couple more other things. Now some stuff about graphs. Graphing vocabulary. Now I'm really making it up because I only have a piece of paper to look at. Do you know what it means for a graph to be increasing? And then obviously the other one's going to be decreasing. Why did I put a T? Decreasing. That's how you spell that.
It's just an off day.
Yeah. So I will draw 2 graphs, and you've got to say which one's which. Just, trying to think of something good, but one's increasing? Which one's decreasing?
First one increases.
First one's increasing? How do you know?
Because it's got a
Because it's
positive
going
slope.
up.
Positive slope. Close. Curves don't have slopes. They have instantaneous slopes, but you learn about that in calculus. Going up. Isn't that one going up? Look at it.
Yeah.
Going up.
You have to read it left to right.
Okay, there's the key. You have to read left to right. Yes. So, goes up from left to right. That is the key. Because otherwise you could say either one of them. You could say, oh, that one's increasing, and that one's decreasing. But you have to go left to right. So yes, this one will be increasing, this one will be decreasing. What is slope?
Rise and fall.
Rise and lower.
Right, okay, classic, rise over run. Give me another just classic, like, thing that everyone says for slope. How about that?
Triangle.
Triangle X over triangle Y, you know what that means?
Change in Y.
Change in Y over change in X. Okay, how about some words now? Just tell me in general, if I know nothing about math, what's slope mean? How much it's going up by?
How fast it's going.
Close. You need a little bit more.
The relationship between X and Y in the graph.
No. How about just the steepness of a line? Steepness. You know the word steep? Yeah. That's like when you make your tea, you put the bag in there and it like soaks. Oh no, that's not that. That's any English majors in the house?
That's C.
That's seep. Yeah. I'm making jokes that don't get something. So I'm just gonna go back to math. Okay, yeah, steepness of a line. Just trying to throw in some other stuff about slope. Curves don't have slope. Slope has to be linear, has to be a constant change in y for every change in x. So how much it's going up by, yes. How much it's going up by divided by how much it goes over by, I guess we could call that, and that's rise over run. Y-intercept. People say that all the time. But do they know what it means, Bailey? You said it earlier.
When the line crosses the y-axis?
Yeah. Doesn't have to be a line. Anything. On the graph, on the curve or the line, you could say line. When it crosses the y-axis. So what's the x-intercept?
When it crosses the
It crosses the x-axis. Looks like I'm not doing a very good job here. Crosses y-axis. What does? Oh, I got two more. That's right. We're gonna have one called continuous, and then one discrete. What do you think about those two?
And that means stops?
Yeah.
Keeps increasing or decreasing?
There we go. Doesn't have points? Which one?
Continuous.
Continuous is generally what you think of when you think of graphs. You see lines or you see curves. Like that's continuous. That's continuous. Discrete is when it's just dots. So, I don't know, line, curve, just points. Shouldn't say dots. So like, remember when we did that whole box thing where you had to cut them out and find the volume?
Yeah.
And then you put it on a graph and it should have looked something like, it went like that. That was discrete because it was you either cut one out or you cut two out. But then when we were talking about, oh, now you can cut anything you want, it became continuous. A better example would be, let's see, we didn't do that. We didn't do the golf ball one, huh? No. We'll do that later. Any graph where you're talking about, like, where the x-axis is like number of children, and then the y-axis would be stress. So this would be continuous or discrete? Discrete, because you either have one child or two or three or four, and they would be dots. And it wouldn't be a solid line, because there's no such thing as having 1.5 kids.
A continuous would be like a heartbeat when, like,
Or are you picturing like the,
yeah, like,
that would be, yeah. I don't know what that measures. I don't know what the y-axis is.
So this
Pressure maybe? If it's pressure, the pressure goes up, and then, yeah, and time would be the x-axis.
Isn't it
But I'm not sure
number
what
of
that measures.
heartbeats per like a minute that it measures? Or how many times you heartbeat?
That's your pulse. But I
Yeah.
think she's picturing, like, you know, when you think of heartbeat, most people think of the thing that goes.
Yeah.
But I don't know the units for the x-axis. I think it's time. I don't know what this is. I don't know what's making it go. Pressure makes sense.
Yeah.
Positive pressure and then a negative pressure is the. But I don't know. I'm just completely. Don't hold me on that.
so discrete, the lines can't be, like, you can't connect the dots.
You can't connect the dots. No, don't connect the dots. Connect the dots. That's the
I have
difference.
2 more episodes.
And that's, I'm giving you those because next week when we do more of your
Barely then.
little graphs that you had on your homework, some of them should be, some of them, I was about to say just continuous. Some of them should be continuous, some of them should be discrete. Depends on the situation, depends on what you're trying to model, depends on what you're trying to display on your graph. Anything else? Give me a math word, Giovanni. Asymptote? That's a good one. We'll learn about that one later. Fibonacci, you know that one? I'll teach you how to cuss in math. So you can tell people to go Fibonacci themselves without being a dumb asymptote. It's great. They don't know what you're talking about. Got any other math words? Anyone know? We know lots of them, right? Okay, I'll shut up now. Boring enough. Trying to think if there's any more about graphs. You know what axes are? Axis and y-axis, x-axis, y-axis. You're not in fourth grade. You know, I think you know everything you need to know. Or. Oh, that was on there. Okay.
I know.
I was like, oh no, I didn't get any of that. Okay, people that were here. Hope you enjoyed this production. The worksheet I gave you is due on Tuesday.
Dramatic.
Anything else for the viewers at home?
No? No question.
Be ready to go hard next week
Yeah.
and take your earpieces out. You guys all look like you're in the CIA and you're like talking to each other.